Hello everyone, welcome to another tutorial video on the tutorial series of object-oriented programming in C++, especially targeted for beginners. And this tutorial video is all about object-oriented programming in C++ with respect to templates. With respect to functional programming using template syntax and semantics, please check the previous video. And this tutorial is all about object-oriented programming. So first let's create a project. Template class. So just clean up as usual. So now the project is ready to go. As far as the object-oriented programming in C++ with respect to templates, there is an exception. We have been talking right to the tutorial series not to use header as the implementation file itself. Put all the implementation into the .cpp source file, and header should just a skeleton is just for declaration. But there is an exception to this. So this is where the template slightly deviates from the normal C++ coding constructs, because we have to put all the functions inside the body of the class header itself, and there is no real need to generate .cpp file. This where the exception comes from. For example, the compile header, you could have seen in some examples of libraries, especially Qt. We have seen that it has comes with the compile header as well. So there's an exception to C++ when you put the functions outside of C++ class header. Somehow there is always some errors that is been thrown out by the C++ compiler during compile time. So one way to circumvent the problem is to put all the functions inside the class header. So how to go about writing templated class? Let's begin the exercise. Let's create a class uh, template object. So we created a class called template object. So let's create, this is the standard C++ template, and we don't need the constructor and the destructor in the source file. Source file will actually delete the source file, because there is always some C++ compilers actually cribbing when you actually implement in the source file, and most of the implementation actually happens in the header. And please check out the templated functions in the previous tutorial video. So here we actually create, we don't need anything private, so we just go it with the public methods, because all the methods should be public typically in templates, because we want to use the function. So as per the variables are concerned, please go ahead with other classifiers like private and protected. So a template object, so we create, here we target 4 data variables: int, float, long, double, and excuse me, we have 4 mathematical operations: add, subtract, multiply, divide. So let's implement first let's convert the class, standard class, into a template class. So with the keyword called template, and angle and the closing angle bracket, open and closing angle brackets. So the another keyword is known as the type name, and with letter T, and so this can be converted into type as per the previous video we just following. This can be anything. The typical what people use is known as T, and we are just demonstrating that you can actually use slightly different than the capital letter T. So let's create 4 functions: add, subtract, multiply, divide, which accepts 2 variables. So return data type for add is this type. So we have var a and var b. So let's define the body of the add program. So it returns var a plus var b. Then we actually define four other functions to do the other mathematical operations like subtract and divide. So please be careful when you're copy pasting not to produce any runtime errors. So divide, so we just change the mathematical operations accordingly. So now we have created four functions called add, subtract, multiply, divide. The return type of all these four functions is this type, which is of type template, meaning it accepts any data type, but will limit to the four data types called int, float, long, double, because this is a mathematical operations and we are adding, subtracting, multiplying and dividing accordingly. So each function accepts two variables, var a and var b, of this type data type. So what to do with this? We just go to the main and we just call the header template object. Then let's create first int two integer variables a and b with 10 and 25 values respectively. Let's create an object of type int object with the class object known as template object with the data type. The template data type is now we are declaring as int. It can be four qualified data types are there: int, float, long, double. But for this instance called int object, we want the template data type to be int, and the object is now the template object. Now the int object has been created. So let's use int object. Int object dot add a comma b. So we are just using the int object we just created, which is of data type int, and the class object called the template object, because we have included the header here, and we are using the add function. So we'll just use the other functions step by step. Let's see whether everything goes fine in the compilation process. Is there any compile time error first of all, and we are following all the data type properly. So we'll remove, we don't need the constructor and the destructor typically for this type of a thing. So template programming is actually highly involved, so we can actually see the add equals 35. So just be careful during converting class, the typical class object to template class object. So there is no real proper way of writing the constructs in constructor and destructor. So we actually remove the constructor and destructor writing when you are writing template class objects, and put most of the body of the program inside the constructor, I mean inside the class body, in between this open and close brace here, so that we don't have to deal with all the complexity issues of the template programming. So this is one of the typical example. As you can see, the add has put 35. Let's see whether we can actually use other three functions known as subtract. So we just rename to subtract, multiplication, division. So let's see whether everything goes fine. So we are not doing anything, we just created an object, and we told the template object, class object, to be convert itself to the data type called int. This is very much important, so because C++ is a data declarative language, meaning at compile time the data type has to be known at compile time, so that the program does not crash in the runtime. So C++ is a data declarative language like Java and C#. So let's see whether everything goes fine. So all four is now running. So we got div equals 0 because a is less than b. So anything numerator less than denominator, and we go for integer type operation, the division actually obviously gives 0. So we got the divide equals 0. This is not a wrong, this is the correct one because the data type is now int. So let's do the same thing for float. We are not creating any new class objects. We just have new variables. So if float flt1 and float fltu. So you can put small letter f as they are saying that the value is actually float. So we use the same thing. We are not changing anything at all, and we need to create a new class object, the templated class object, and tell its data type to be float, and we create a new class object called float object. Float object is the templated class object of template object, and the data type we have told to convert itself to float, and rest remains the same. And we have created new two variables, so we have to convert this a and b to float. So we are not changing, we are not creating any additional classes, meaning one for int, one for float, one for long, one for double. So we just created one templated class object. We removed the constructor and destructor. We created the functions inside the body of the program, and we have the keyword called template, and this is the syntax that needs to be included to convert the class into a templated class. And we have the templated data type called this type, and we have four functions. Each function accepts two variables, var a and var b, of data type this type, which is template. And we included the header. We created a object, int object, and told the class object to behave as a, meaning behave as integer object. We created another object called float object and asked the class template class object to behave like float. So let's see, just for pretty printing, we'll just add so that it's actually visible in the just doing some pretty printing thing. So let's run the program and see is there any compile time errors. So there is no compile time, the program runs successfully. So integer has run. So here the next is the float. The float has actually also run. So if you want to be double, so we don't have to create to add f. So we just run the program, it accepts but convert implicitly gets converted into float typically in the C++ compiler. So let's see the division, is there any issue? So there is no issue. So as people can see, we just created one class and we ran two data types on it, int, float, long, double. So let's create one more known as the double. It's just to demonstrate. Just created the double. Then we need two variables of type double. Renamed as d1 and d2. So let's run the program. So we have to create a double object. So here we haven't converted that to float object, that's why we are getting some issues in the division. Sorry for the typo. So I've just updated it. Let's see what the results. So you can actually see the division is not 0, it's actually coming as a decimal because I forgot to replace the function names as float object. This is the problem when you do copy paste. Actually I'm trying to more concentrate on explaining the stuff rather than looking at the code. So sorry for the typo. So I replaced all this float here, so we get the float values here, and we the double is running. So as people can see, we didn't create any 3 class objects. We just created one template and asked the template to behave as int, behave as float, and behave as double. So this is the entire content is in the body of the program. There is no constructor and destructor. This is the slightly deviates from the norm of the standard class object, where we have constructor, destructor, and we create this skeleton, meaning we declare the function and implement the function and the body of the function in the .cpp source file. So these are the variations from standard class object to templated class object. So this tutorial video is all about a templated class object. So this is the standard way of doing the template object. So we just created one templated class object, and we asked it to behave in 3 different ways: integer, float, and double. So all 3 are running without any code change. This just changes at compile time, meaning the code get dumped at compiled, and at runtime the actual content will be running, so that we'll get the actual results. So I think I will end this video here, tutorial video here. Thanks a lot. Thanks for staying this long and watching this video. Please stay tuned for the additional videos coming up in this series. Thanks a lot. Bye.